SDRs let you work with RF, or radio signals, on almost any computer. It's cool because you can learn a lot more about the data hidden inside radio signals, like these digital signals hidden inside normal FM radio broadcasts here in the US. My dad and I use a lot of cheap SDR dongles like this Newelec or the RTL SDR that starts around 40 bucks. But there are models like this one that costs thousands of dollars. Is that even necessary for the things we do? And how do you get started with one of the cheaper models? Well, since we got an early preview of some new hardware, this Hydra SDR RF1, I thought we should make a video talking a bit more about SDRs. And starting off, I guess I should ask you, what do you do with these things?
Radio engineers have interest in several frequency bands, AM, FM. We do supportive frequencies, 160, 450, 950 for STL and talking to trucks and things like that. We have Wi-Fi just like you do. We have the 11 gig and higher now point-to-point for high-speed data to our tower sites. And we look at the spectrum in general for things like when I put in EAS receive antennas, you want to see how clear you are, what frequencies are out there, if anybody's in nearby interference going on, and fix that.
And you brought your laptop with you, and we have the Hydra SDR, but you can do this on any of these, right, especially the FM band. But can you show me, tell me what I'm seeing on the screen here?
Well, I've tuned in for FM, and I'm on 90. You can see here, and I'm on 96.3. That's because it's right next to my station here that I watch. You see that little dot there? That's 96.7.
I noticed that there's this is a very faint blue compared to these very bright
high
signals.
Power, low power, high modulation, average modulation. Yeah, but so what we look for is anything that's an anomaly, and that would include at times when the channel 96.3 was having trouble with their HD channel, and it would put out regrowth patterns from the digital carriers, and it would wipe us out right here. And I could see it easily on here, so I used to sit there, and you can right-click on this, for instance, and now I'm getting peak values, and I could come in the next day, and I could basically see anything that popped up. Now, what's interesting is you can also see stations that come in from out of town. They drift in sometimes. You can see that kind of thing by using a toy like that, just putting on the peaks, whatever. But anyways, then look for other stuff. So other stuff we look for is like, we noticed that little guy right here. There's a little guy, you can see him easy right there. And he is a spike that's either real or not real. And you look for stuff like that, and if the signal is higher there, is there something's popping up and down right there. But that one's pretty steady. So like there's probably somewhere, if it was something going on, there'd be somewhere again and again and again, somewhere we'd be able to tie that up to whatever its interference is. And then there is something popping up here right, every once in a while that looks not correct.
And what are those things, like I've heard those called Spurs.
Spurs, yeah, that's a spur. It's a little spur as it pops up where it's not supposed to be. A lot of times, you hear people talk about the harmonics of a bad transmitter. It'll put out harmonics, so it'll put out waves, and of course it gets less power as it gets away from the center frequency where everything's tuned to broadcast. But and then here, like, see, this is like a little HD, a little bit of regrowth. It's on both sides. It looks like their transmitter is not suppressing the regrowth too well today. So that's kind of an interesting thing. So these are things where, as an engineer, I would call the guy at that station and say, hey, I'm seeing this. Are you too on your $10,000 piece of gear, right? So, and I have the benefit of having played with some of that stuff. So you look here and you see this could be real, this couldn't, because that's the number one thing is you got to kind of know your tools before you call in the police, the FCC or anyone of what you're looking at and make sure it's real. So a $20 used dongle, probably not a good idea to call that one.
So you're saying that like these, you wouldn't want to call the FCC seeing something on that, but maybe if you see something on this, $10,000 SDR,
exactly,
then it might be a little more verifiable.
Exactly, and even things like this antenna sitting here. There was one of the stations. I was reaching my hand in to hit the keyboard, and I saw the HD carrier dropping with me reaching my hand. Right. So I'm actually tuning that antenna. So is this a good antenna to no, that's not a good antenna to use to, highly accurate readings of any kind. And then we've got things like this guy right here, which I use to kind of just a cheap man's way to look for AM energy where it's not supposed to be, and look for energy where it is supposed to be. This is not a calibrated antenna by any means, but it's a good sniffer. So those are just some of the tools that I found useful in the broadcast world. So
once you have a good antenna picked out and you get a clear signal on here, I noticed you have all these other graphs, and I saw earlier you even had some other tools up too. What do you like? I don't know what these are, and then what are all these little things that are sticking out of all these graphs too?
Well, this is interesting. So this one over here, this is showing the composite, the MPX spectrum. So this station has audio here, left plus right mono. It has a 19 kilohertz pilot, which tells the receivers that you can decode in stereo. It has a 19 kilohertz, 38 kilohertz carrier. This is the left minus right signal, which right now they probably have a mono commercial playing or something like that because there's no energy here at all. And then these are data carriers. Yeah, see this energy pop up? So now they're doing extra stereo audio, and you got energy here. And then up here is 57 kilohertz, and that gives us this data up here. It comes through that, I guess that's a double sideband something or other there. I've never really looked at it that way. I just know the carriers are up and working. And then they could have other carriers for other SCA data, like if they had traffic data on the station, they might be pushing that out too. But I don't know if anybody's doing traffic over that anymore. But this is the way you look at it. You can see different information, and this is just the audio band. You're looking at up to 15K, and you're seeing at what frequencies energy's moving. So you can see when there's talk radio, it starts cutting down here a bit, and you see a shelf, and then it pops up and modulates up there. But this is music, so you're going to see stuff always up to 10 or 15.
And then I noticed there's also these two things on the sides of a lot of these stations, but not all of them.
Well, the waterfall, yeah. So these guys, these are the HD carriers, digital radio carriers here. So these are a series of a bunch of individual carriers going on and off, quadrature modulated, I believe. I'm not the expert in that, but I find out what I need to know, and I need to know on that one. But the digital carriers, and you can see there's constant energy at the same level that's being seen in the waterfall. And then this is the analog, the old analog that's been there since FM was invented. That's the analog bump, and it modulates a lot. And you can see my station, it talks right here. You can see there's a lot less width, and there's a lot thinner. It's just talking. So besides the fact it's small, we'd see that on like this FM station here. That's probably might be talk right now. But you get this wider band, a lot of energy going on when the station is doing their stereo, and you can see how wide at the instant in time how much energy is spread out. This one too, playing music here too. So.
And so as an engineer who has one of these weaker signals, what are some things, like have you found anything? You mentioned earlier that there was like a thing from this station that was
regrowth.
Interfering.
Yeah, regrowth, and that regrowth, what happens is the digital transmitter, because it's digital, it has a lot of energy that can bounce and I don't know what you call that with the amplifiers, but they can put out energy. So they build filters in, and they pre-distort the signal sometimes to get distortion in where it would want to pop up. It puts negative power into that area. But you can see here, I think this guy here looks like he's got a little bit of regrowth above and below. So see, he's got his HD carrier. It might be a little bit of regrowth only because I was seeing it above and below. But again, I wouldn't report that to him. See, and now I'm not really seeing much below at all. But again, so if I zoomed in on that, and again, these things, that's another thing to talk about, Jeff. They actually have options. There's a lot of options here.
Another thing is, like right now, one thing that I like about this box is that it looks like you can see a lot of the FM band. So whatever signals you're looking at, you get more bandwidth, I guess. Is that what it's called?
Yeah, and that's something we should learn in detail. But the ability, how many samples can you take so that you get enough resolution for every channel that you're looking at once, right? That's one of the ways to think of it. And these boxes are all set up where you can change that. And what do you call that?
Mega samples.
Mega samples per second. Yeah. So that that's the taxing thing on the hardware and the computer.
Because I know with like these guys, the cheaper ones, I can only see like
a little bit
this much of the band at a time. So it's kind of like a window, and you're kind of moving it around to find the signals you're looking at.
Yep.
Whereas this one, you can see more of it. And the other thing I noticed with some of the cheaper ones, especially with the bad antenna, is it kind of makes a hill. And the signals in the middle, you can kind of get better, but the ones on the edges, you don't see at all.
Yeah.
Or they get stuck in the noise.
Yep.
So,
yeah.
And I noticed your gain is turned all the way down. A lot of times when I'm doing stuff, I have to turn that up to get any signal.
I'll tell you what, a thing about gain is I like to try, see it without. Let the antenna receive a good, strong signal. Well, the signal's 30 miles away, you're probably not going to be doing as you're like a mile away here from some really good signals. So I like to start with no gain, but just to show you, you do something like this. But if you need it, just to show you, if you start pushing the gain, I'm getting a higher level of noise, and eventually the noise is, now I'm amplifying so much noise, the signals aren't as clear. But there's a point where you can kind of trim it down, where you're getting some gain, but you're not messing with it. But mostly all I'm doing right here is I'm raising the noise floor and the signals. There are times when you will raise, the signals will go up, but the noise floor won't go up as much, and that's a good use of gain. But there's so many settings on these. It's wonderful to play, but it's a pit, so you don't do it when you're ready to go to bed.
I notice also you have AM, LSB, CW. What are all those things?
You always have to pick your mods. This is your demodulation. So this is wideband FM, which I'm looking at FM. If I was on the AM band, I would go to AM. And it has lower sideband, upper sideband, continuous wave, DSB, which I never used that. DSB.
I know that FM is one interesting band, but we also have a couple of these Meshtastic radios here, which, we can send messages back and forth. Is that something else we can see on here?
Yeah, you can. If I go up here to, we're at 9, go down. 905 or so, somewhere here. And again, this is where you want to see enough of the band. If I go to my, hey, a new node has been discovered. Show my phone on your camera. You send it to Gearling or to
the full long fast.
Yeah.
I don't think I'm even on the Gearling one. So if I send this message on long fast.
Let's see, you should see it.
Oh,
there you go.
We did get something.
And I got it here, test from.
Oh, and you sent a message.
It replied and said, I got it. Yeah. So you should say acknowledged or something.
Okay, I'll say A-C-K. ACK. Send, and there it is.
And then I send you a test back, and there's my test back.
Okay.
Boom, there you go.
So we can this is digital, I presume, right?
Right, and so you could go in and you could start analyzing that signal. You could literally go in and try to centerline where your devices are currently talking.
Send another one really quick.
Yeah, so right here, again, you got to see what it's trying to do there. Oh, we're not hearing it. It's going to be recorded there.
No, yeah, but
see that,
is it getting anything here?
See, now with peak on, you see where it's showing the stuff going on? It's waiting to be acknowledged. So if I go back to...
something else is sending. So
yeah, no,
it looks like
it's coming.
Yeah.
Yeah.
Meanwhile, anybody who's on the mesh here in St. Louis is like, what is going on? These guys are nuts.
Yeah, you can see the send and the...
If you are in St. Louis, we have meshstl.org or something like that. There's a group now.
Yeah.
And there's an EAS channel and some other stuff, so cool stuff happening there. We're going to go to open source.
Yes, we are.
I'm sure that open source will have some interesting things too.
They definitely will have some Meshtastic action there. So.
And I think this is the danger of doing SDR stuff is you get so deep into it and you'll go into different parts of the band and you'll be like, oh, I could see some Wi-Fi, I could see some 5G, all these different things. Like we haven't even been doing anything. I don't know if that's like one of the stations is sending out, it's like, here I am,
exactly
this is who I am.
Yeah.
But there's so much going on around us that you never see because our eyes can't see RF. Yeah. But I did want to point out there's a lot of other YouTube channels. One in particular that I really enjoy is Save It for Parts. He goes a lot into satellite reception and the antenna design behind that and where to point things. There's just so many rabbit holes you can go down. It's very cool. But something else that was interesting to me that I know almost nothing about is I noticed a lot of things have these little guys, which I found are ferrite chokes.
Yes.
Why? What is the point of this? Especially like this is USB. I thought it's USB. If there's a signal, it's a signal. You're good, right?
Yeah. Well, tip the hat to Jeff Welton again. He's a big RF choke guy in broadcasting. But the RF chokes, they're all around. You see them on power cords and everything. They resist energy flow. Anything external to the wire gets resisted by hitting those. So, why guys design like there's 2 within 6 inches and other guys have 1 on the one end.
Well, I even noticed your power supply has one. The power supply for this little HDMI recorder, does it help? I've noticed that things that have them, it seems like people care a lot about them. So it seems like somebody designed it into the system instead of just like throw them on everything.
Yeah. And again, I would say
and someone here.
Yeah, there's some on there. There's some USB cables we get. But it's, you just look at it as anything shooting through that, any abnormal energy gets resisted. because of the nature of the ferrite material. And I guess that's the most protection. I don't know if it's always used in power cords for protection from spiking, or whether it's looking for some other energy that's just not supposed to be there. High frequency, low
RF
frequency
interference with other devices around it.
Well, that's
Because I noticed the other thing too is even like the coax cable, like all these cables are slightly different. They're different thicknesses, they have different shielding.
yeah.
But you were talking about the RG58 or the H11, whatever the cable is that I'm using for the GPS antenna.
Mm-hmm.
You said like it does make a difference.
Yes, cable makes a difference for many reasons. It's like a whole science in itself. It's and you never go bad buying really good cable. That's just a fact. And the other thing I was going to tell you, we use chokes to keep RF out for sure, off of like control lines and things that are slower than the RF. Never a bad thing to see those. Never a bad thing to use good cable.
So, choosing one of these things, I think when you're getting started, you want to get something cheap, and you can get these
Yes,
used
you do.
too. So if you know any ham friends, I bet they might have one of these sitting around in a box.
That's a great thing to do.
I have like 5 of them, so if somebody ever comes up to me here and says like, man, I really want to get into SDR, I'm just going to hand this to them because I don't need this many of them. But yeah, getting started, it's like $40, and you can get kits that come with a basic antenna,
yep.
basic cable, this guy, and these get a little bit hot, so make sure you're not like putting them on top of something you don't want to get hot. But that's getting started. And then the thing I like about that is it teaches you quickly the limitations of the cheap ones. And you might see some weird noise and stuff, and then you're like, okay, now I know the software enough, I can at least get it plugged in and going. Now, do you want to get one of these guys or one of these or one of these guys if you're doing like scientific work?
Yeah.
So it's a cool gateway drug. Even like this Flipper Zero, it has a built-in little like spectrum analyzer that you can see signals just like the waterfall there. Is this high quality? No. Is it fun and interesting and gets a lot of attention? Yes. It's an interesting little tool for that. So whatever way gets you into it, I think is the key.
Yeah.
Because there's a lot. It's not just radio. It's not just hobbyist amateur stuff, but the FCC and 5G communications and wireless, audio and video transmission. There's tons of things.
See what's going on in your house, all that stuff. And I would say, when I first got one, I would say you need to get one. But I think now you need to get 3 or 4 and maybe 5.
Well, that's an interesting thing because, the reason I have all these is because I was like, I want to do FM and I also want to have an AM thing and I want to have these connected to different antennas. And I want to be able to do whatever I want without having to go up and unplug and replug. And then along comes this Hydra SDR. That's the reason I wanted to talk about this in particular. It has open firmware. It's from the guy who made AirSpy and all that. But this little box, you'll be able to, I don't think you can yet, but you'll be able to buy a little faceplate so that you can have 3 of these stacked inside. It's going to get hot. You might want to find a way to cool this a little bit better because even this one is a little bit warm already. But that's a cool thing. You can have 3 or I think up to 10 at some point. That might be a stretch goal, but you could have all those sitting here in a little box next to your computer or, when you're out and about doing stuff, and you can have them all doing different things.
Right.
If your computer has enough horsepower, of course.
Right.
But this does work on a Raspberry Pi as well.
Yeah, and that's one of the things we'd probably be testing. I don't know if we'll come up with any video stuff on that, but it is interesting to see where you can go with these things. And sometimes it's about what's enough. Like sometimes it's just enough to see a plus or minus 20% of accurate thing, right? And sometimes you want to get super accurate. So
yeah, like before you call the engineer about the Spurs and stuff, you might want to have good equipment.
Yeah, don't cause him grief. He doesn't need to know. But do call your engineers first and your buddies. Most ham people, most AM, FM, TV engineers will be very helpful with that.
And one little bonus thing at the end of this video, you brought this thing, which I had not seen before, but practically speaking, a lot of times you want to go around the St. Louis area and take measurements at different places. And you showed me the band scanner too. Yeah. Can you tell me a little bit more about it?
Well, this is a device that I had a great need for and was able to fund. It helps me to drive. I can drive, rig my car with antennas, drive anywhere I want, and the GPS input records the location, and the antenna input records the signal. So I can tune to a signal, drive a path, highways around a city or whatever, and it will log it, and I pick the interval of the logging points and all that stuff, and then I can map it on, what's that company that makes that mapping software? It's all the world. Google, that's the one. Google, but
This is made in Bulgaria too.
Yeah, made in Bulgaria.
Interesting. from Diva Broadcast. And I noticed, so there's FM antenna input, which we have, it's antenna input
there, yeah.
But this is probably tuned for FM.
Yeah, this is mainly...
It has GPS antenna, but then there's MPX. What does that mean?
The MPX, it gives you, you can analyze your MPX, you know, and I've never used that. I don't even know if it's an input or an output, but you can okay, so you can analyze an MPX signal. And again, for FM guys, you could tee off your multiplex output, put it in there, and you'd see it. And you'll see the software shows you kind of the magic of it. So when I look at this stuff, I'm seeing RF, and I'm seeing some things that are sort of decoded in, but this one gives you a lot of information that you want to know when you're actually setting up your modulation. And
it gives you position data. So you can say, like, when I was over at this place, this happened.
Yeah. So it gives you an RF signal level. It gives you your composite information, breaks it out, left, right, stereo, gives you an oscilloscope type view.
Well, why don't you, can you show it?
Yeah, sure.
It'd be cool to see.
Okay. And you could use 6 adapters. Some people can figure that out.
There's insertion losses with each one.
Yeah, I think I got it. Okay. You definitely want to make sure that's a good thing. And then Jeff has had such great success with his GPS world here that I'm going to use.
It's not going to work inside here. It might.
You
might get a couple sats.
You never know. And then my the particular cable that I carry around, which you notice does have the Ferrite chokes on it. This guy goes in the front. And this guy, I'm going to flip the cables sloppily there, Jeff.
It's USB. How many times? Oh, you didn't have to flip it at all. Good job.
Okay, now that'll come on and start blinking, and you'll eventually see it has a light on and everything. And then I go to the software. So you can see it has a lot of information on it. And when it gets up and starts down here is where I'll tune the antenna. So it does a scan of the whole FM band automatically. So it's on a station already, 98.1. Yeah, see, and you can watch, like here's your LUFS, loudness. So you've got your different kinds of measurements. You get measurements over time. And that's the characteristic that they had at the time. That was a changing thing, but I think we're all settling into now for loudness to check our loudness.
We got GPS. It looks like it's close, but it's not getting those signals. They're not inside here.
Yeah.
And the patch antenna.
It would show
the right way, right?
Yeah. So those. These you can show the signals of several. I've had as many as like 11 at a time that I know. Look at that now. They went down to 0. But it's got the text data up here. So you could see a lot in one screen of things. And all this gets recorded because it's actually not recording all of it, right? It's recording the RF, and then it can recreate it anytime you want. So and it has audio output and all that kind of stuff. So it's great.
This is basically like the, if you take SDR to an extreme of like optimizing it for one use case, you end up with these kind of products where it's, this is SDR for FM purposes with lots of good software tweaks to make it very useful.
Yeah, it's very good.
So thanks for spending a little time with us learning about SDRs. What's your favorite hardware if you already have one of these things? And let us know what other use cases you'd like to see us covering in the future.